Okay, I'm going to try and zip through the slides in this deck pretty quickly. There's 77 of them, but I think we can go through it pretty quickly. So the mechanics of time value of money. When your problems get very complicated, it helps to lay out a timeline like this. And so the assumptions on the timeline and the assumption of your calculator and Excel all are that cash flow zero is today. So cash flow zero is a one-time cash flow at the present, and that time is today. Usually we're dealing in terms of years, and so cash flow 1 would be a year from now. So if this is January 1st, this is December 31st of the same year, and December 31st of 2 years from now and 3 years from now. So that's kind of the assumption of the timeline, and it's typically the assumption when you lay your cash flows out for your calculator or Excel. So we are going to look at finding the future value of $100 after 3 years if the interest rate is 10%. So the $100 is happening at time 0, and then we're asking what will it be worth 3 years later down here. So after the first year, we earn interest 10%, so we've got $110, right? So then in the second year, we start with 110 and we earn interest and we get 121. And in the third year, then we start with 121 and we get to 133. Okay, so obviously you're not going to do that 1 year at a time because that's much too laborious. So we can generalize it and say that the future value at any time n is equal to the present value times 1 plus I to the nth. So in this case, the future value at time 3 is equal to 100 times 1.1 to the third is 133.10. So that's the algebraic way of solving it, and for simple problems like this, really this is the way I do it. It's easier than using even a financial calculator. So 4 ways to find future values, step by step. Never do that. Solve it like we just did. Use a financial calculator or use a spreadsheet. So the financial calculator here, so this is for an HB 10B too. And so when you first get your calculator, and we should have solved all this in New York, but so
Clear.
the first thing that you want to do is 2 things to set your calculator up. Let me move this down so you can see better. So we want 4 decimal places, and so the orange key activates the things in yellow. And so if we say
Orange
key,
function. Display decimals.
and then
Set
hit
4
4
decimals.
Now I have 4 decimals there, and that will just come in handy when we're doing work later on. Sometimes an interest rate answer is out in the 3rd and 4th decimal. The second thing that you want to do is if you do
Orange function.
clear
Clear all.
See, it says it was set on 12 P's per year, so that means monthly compounding. And so I want 1 orange
function.
payments.
Store payments per year.
Okay, so now if you hit, so when you hit the clear key, it
Clear.
clears what's in your display up here. If you want to clear what's in memory, you have to do orange
function.
Clear all, and now it shows 1 P per year. So now I'm set up to do something correctly. So for this problem, we input our present values usually as a negative amount. So the idea is I invest $100 at time 0. So I'm going to type $100.
0. 0.
And I'm going to change the sign to negative right here. There's a plus minus key.
Change sign.
To show it's an outflow and call that present value.
Store present value.
And then we had 3 years, so 3 is N.
Store number of periods.
The interest rate is entered as a whole number.
0.
So 10 is the I per year.
Store interest rate per year.
And I want to know what's the future
Calculate
value.
future value.
Okay, so there it is, how to do it on the financial calculator. So if you know 3 things, you can find the 4th. If you know 4 things, you can find the 5th. So you want to be very literal with the calculator. So if I had put the $100 in as a present value, it would have given me a negative future value. But the idea is that you have to invest to get back. So the $100 is an outflow, and it comes back to you as 133.10 at the end. And so here are the steps like I just did. So 3 is N, 10 is I, negative 100, 133.10. Okay. If you're doing it in Excel, if you go into the financial functions, f of x, and you will find the future value, and then it will prompt you what is I, what is N, what is payment. And so this means that you have to have, well, you can type in stuff. So you could just type in the numbers, or you can have it set up somewhere where you can point to it in your spreadsheet. So what is the present value of $100 due in 3 years if the interest rate is 10%? So this is going the opposite direction. So that what we just did is called compounding. What we're doing now is called discounting. And so algebraically, to find the present value, we're dividing by 1 plus I to the nth. Okay, so the future value is $100 divided by 1 plus I to the nth, and that's 7513. On the financial calculator, it's just like the last problem. So in this case, we know the future value is 100, we know I, we know N, and we solve for the PV, which is 7513. Okay, and likewise in the spreadsheet, we use the PV function and we input what we know and we solve for PV. Okay, we can find the interest rate. And so algebraically, it's the same thing. The formula is PV equal, or future value equals present value times 1 plus I to the nth. And you can solve for whatever you need to solve for here. But again, you're probably not going to be doing it algebraically, I hope. And so using the financial calculator, it's super easy. We put in these three that we know this time, and we get 25.99. I'm not sure what this -1 and this -2 are. What was our original problem? Finding the interest rate. Oh, 1 and 2. Okay. So -1, 2, and so the interest rate that gets you from 1 to 2 in 3 years is 25.99%. In Excel, it's the rate function. Okay, it's not the interest function. The interest function is something different. So it's the rate function in Excel. But again, you put in what you know and solve for what you don't know. Now, annuities are equal annual or equal periodic payments. So the payment is the same every period. It could be a year, it could be a month. But the timing of the annuity is important. So an ordinary annuity assumes that the first payment comes at time 1 and then there's one every period. An annuity due starts at time 0. And so the payments the same number, but they start, like in this case, it's a 3-year annuity. So in the ordinary annuity, they would come at time 1, 2, and 3. For the annuity due, they would come at 0, 1, and 2. Okay, so if we're asking what's the future value of a 3-year ordinary annuity of 100 at 10%, so the time 3 cash flow doesn't earn any interest, right? It's there at time 3 and it's just there. This guy earns interest for 1 year, this one earns interest for 2 years, and so if you add them all up, it's 331. Okay, so this is the formula. Again, I don't think you're ever going to be doing it using the formula. So using a financial calculator, your calculator is set on end mode, and end mode means ordinary annuity. Bring this guy up again. So beginning and end here. So again, if I do the
Orange, clear all.
see, each time I put the calculator down, it's resetting to 12 P's per year.
Orange function.
But so
Clear all.
it didn't say anything about beginning or end. So if I go orange function,
Set mode to
now it says
begin.
begin, and so it's in begin mode. And so that's going to shift the cash flows 1 year to the left. Okay, so I'm going to get rid of this. So for an ordinary annuity, it's in end mode, and we've got 3 ends. And this time we're solving for future value of a payment. And so again, we put the payment in negative. As I invest $100 a year, what will I have at the end? My positive value. In the spreadsheet, it's using the future value function in the financial functions, and it's just like before. You put in the variables that you know and you find the one you don't know. Okay, so what's the present value of this ordinary annuity? So you could discount the cash flows one at a time, or you could just put it in your financial calculator and solve for PV, or you could use Excel and get the same answer. So if you have an annuity due, it's going to be worth more, right? Because in the ordinary annuity, the last cash flow didn't earn any interest, and this one earned interest for 1 and this one earned interest for 2. In the annuity due, the last cash flow is going to earn interest and the first cash flow is going to earn interest for 3 years. So an annuity due is more valuable. So the present value of an annuity due, you could find the present value of an ordinary annuity and multiply it by 1 plus I. That's one way to do it. So that's the future value of an annuity due. Or you can put your calculator into begin mode and then just input the variables like you normally do. So in begin mode, we find out that the present value is negative 273 and the future value is 364. Okay, so that's on begin mode. So if you put your calculator in begin mode, you got to make sure that you put it out of begin mode after you're done with that problem, because the normal assumption is that we're going to be in end mode. So in Excel, the very last thing over here is it's 0 if it's end mode and it's 1 if begin mode. So normally the default is 0. So normally when we put our data, we just ignore that. But if you do have a begin mode problem, then you're going to put a 1 there to say that it's in begin mode. Okay, uneven cash flow streams. So here, this is not an annuity, so these can't be called payments because they're different amounts every year. And so again, you could always discount them one at a time. So you're dividing this one by 1.1, this one by 1.1 squared, this one by 1.1 cubed. That's way too much work. You don't want to do that. So I'll see if I can demonstrate this with my emulator's not working great. But so So here's the cash flow J key, and this calculator is very literal.
Clear.
And so the cash flows were 100, 300, 300, negative 50.